And then I'm going to, I haven't written out the homework yet, but I will adjust the homework from there. Okay. Alright. Okay. So, we're going to use the new formula we had yesterday. Okay. We're supposed to find the exact value of the trig function that's given. They're wanting us to do the sine. So the first thing I'm going to do is I'm going to write out my pattern that we did yesterday. Okay? So what's the sine pattern from yesterday? Sine, cosine, cosine, sine. And then what operational symbol am I going to put in? Adding, because I'm going to keep it. So sine, cosine, cosine, sine. And then this one's in U's and V's, so I'm going to plop in U, I'm going to plop in V. Plop in U, plop in V. Alright, so I need the sine of U. Do they give that to me? What are they telling me the sine of U is? 4 over 5. Alright, what about the cosine of V? Do they give that to me? Yeah, what's the cosine of V? Good. What about the cosine of U? Do they give that to me? No, so I need to figure that out. Okay? Notice it tells me I'm in quadrant 1, so all of my answers should be positive, right? I'm going to draw my triangle, so I'm going to use my right triangle trig to help me figure that out. So this is my U triangle. In SOHCAHTOA world, what is sine? Opposite over hypotenuse. So my opposite is 4, my hypotenuse is 5. Okay, so what does that make my other leg? 3. So what's the cosine of that triangle? 3 over 5. Good. All right. Do I have the sine of V? No, I could use this information here to figure it out. In quadrant 2, is the sine going to be positive or negative? All students, right? It's positive. I'm going to go ahead and write a plus sign down so I remind myself that I've taken care of that part. Okay? Now I'm going to look at my triangle here. So my V triangle in SOHCAHTOA world, what is cosine? Adjacent over hypotenuse. So my adjacent is the negative 12. My hypotenuse is 13. What does that make my other leg?
10 or 11?
5. 5, 12, 13. And if you didn't know that, what do you use? Pythagorean Theorem. Hopefully we don't have to do Pythagorean Theorem. Most of them are ones we should know. Okay? But if we need to, we can always go back to Pythagorean Theorem. All right, what is my sine then of that triangle? 5 over 13. Good. All right, if you don't know 5 times 13, you should, because it comes up a lot. What's 5 times 13? 65. And aren't they both the same denominator? So I'm just going to take a shortcut and write it over 1 because I'm being lazy. Okay. What is 4 times negative 12? Negative 48, okay, and then 3 times 5 is 15, and negative 48 plus 15 is?
Negative 33.
And I don't think that reduces, does it? I think that's as good as it's going to get. Okay. So we're going to use a lot of right triangles today. We're going to have a few that we do off the unit circle, but it's the same idea as what we were doing yesterday, but we're just applying it slightly differently. All right. What is my cosine pattern? Cosine, cosine, sine, sine. And what operational symbol are we going to use this time? Add. It's opposite. Okay, so for cosine, it's the opposite, where we change it. All right, and then I'm going to plop in my U and my V and my U and my V. All right, so I know I'm going to need those triangles, don't I? So why don't we just set the triangles up now rather than doing them later? Actually, it looks like the same triangles as we had last time, doesn't it? Yeah. All right, so the U triangle, we said opposite and hypotenuse, and my adjacent was 3. And then in quadrant 2, we know that that was negative 12, but we decided that was going to be positive 5, and this was going to be 13. Okay, so it was the same triangles we had in example 9. All right, what is the cosine of U? So you've got to look at the triangle. So what's the cosine of U there? 3 over 5. All right, what about the cosine of V?
Negative 12.
Yeah, read it off. So always go back to the original if you can. Okay, don't make that way you don't make a mistake reading it off the triangle. All right, what about the sine of U?
4 over 5.
4 over 5. And what about the sine of V? 5 over 13. Perfect. What's my denominator again? 65. Good. All right, what's 3 times negative 12? Good. And 4 times 5? 20. All right, so what's my answer on this one?
Negative 16 over 16.
Good. Give you a minute to catch up. All right, are we good with 10?
Yeah.
Okay, 11. So, same triangles again, right?
Yeah.
So I'm going to write them up there again for reference. My U was 4, 3, and 5, and my V we said was negative 12, and that's important this time, and 13. All right, so my tangent pattern was a little bit different. What operational symbol do I start with in the top?
And negative.
A negative, and in the bottom it's 1 and the opposite of that sign. So we know we're adding or subtracting the tangents on the top. What do we do with the tangents on the bottom?
Square.
Multiply them. All right, so, and then I'm going to plop in UV, UV. So that's the formula we have to fill in. Okay. All right, so what is the tangent of triangle U? Here you're going to want to use this over here. So what's your tangent of that triangle? 4 over 3. Good. What's the tangent of the second triangle, the V triangle? 5 over negative 12. What's going to happen with that double negative?
Cancel.
Going to go positive. Okay. I'm not worried about simplifying quite yet. All right. And then the tangent of U again was 4/3, and the tangent of V again is 5 over negative 12. Okay. Let's look at the numerator first. What's my common denominator for the numerator? 12. Good. So what do I need to multiply the 4 by to get it to the right, to an equivalent fraction? 4. So 4 times 4 is 16. Do I need to do anything to the 5?
Yes.
No, it's over the common denominator. All right. If it was me, I would probably simplify a little bit. How many times does 4 go into 12?
3.
3 times, right? And it's a negative 3. So it looks like I've got 1, and it's going to be a minus because of the negative, right? 5 over 9, is that right?
Yeah.
Can everybody handle that? All right. What am I going to turn that 1 into? 9 over 9, good. Just so you know, I'm skipping way more steps than I did last year. Yeah, you guys are awesome. I just need you to do your homework. Okay? All right, what's 16 plus 5? 21, good. And then 9 minus 5? 4 over 9. And you guys, some of you may have skipped this and gone right to the flip, and that's okay. All right? If you're not ready for that, that's okay too. All right, I'm going to go to the flip. I know I could reduce the 21 and the 12, but it's all going to fall out here in the next step anyways, so we might as well just go to the next step. All right, so I'm multiplying by my reciprocal to get rid of the double fraction. Let's see, what goes into, oh, I don't know, 9 and 12 both. 3 into there, 3 times it into here, 4 times. Is there anything else I can do? Doesn't look like it. So what's 21 times 3?
63.
63. And 4 times 4 is?
16.
16. I don't think anything else goes in there, right? What happened? We didn't get the same thing I got last year. Did I get... Oh, I somehow got a 14 somehow. Yeah, I don't know what happened. All right. Everybody good with that one? Okay. So we're going to go ahead and move on to 12. 12's a little bit different. Okay? All right. I am going to... So notice they didn't give us... the trig pieces. They told us arctangents, and we've done this a little bit before. I'm going to try to evaluate those two things first, and then we're going to use our cosine pattern like we did before. So I'm going to draw two triangles, okay? I am going to draw the... Let me think about this if I want to do that first. No, I don't. I'm going to have to do it the way I did it before. Okay, I'm not going to draw the triangles yet. So, cosine, what's our cosine pattern? Cosine, cosine, sine, sine, right? And what operational symbol am I going to keep? Or am I going to use? Negative. We got to change it, right? And then our angles are arctangent of 1 and arc cosine of x. And arctangent of 1 and arc cosine of x. Alright, so this is weird. Alright, so we're going to have two triangles. We're going to have our arctangent triangle, okay? And we're going to have our arc cosine triangle. Alright, remember there's always a 1 in the denominator. I'm going to use this as my reference angle here, and this is my reference angle there. I gave them A and B names, no reason in particular why, okay? Just at least know where your reference angle is. Alright, so what's tangent in SOHCAHTOA world? Opposite over adjacent, so it'll be 1 over 1. How would I get this other side? Or the hypotenuse? Pythagorean Theorem. If you didn't recognize the pattern, there is a pattern on that one. So what's 1 squared plus 1 squared? 2, right? And then I'm going to, how do I undo the square? Square. So that other side is square root of 2. It's a 45, 45, 90. That's the pattern. Okay? All right. The arc cosine triangle, it says that, what's cosine in SOHCAHTOA world? Adjacent, which is x, over hypotenuse, which is 1. So again, I'm going to have to use Pythagorean Theorem, and I know I didn't leave myself a whole lot of space. I'm going to squish it in right here. So x squared plus question mark squared equals 1 squared. I'm solving for question mark squared, right? What's 1 squared? 1. And then can't I subtract that x squared to the other side? And then how do I undo the squared? Squared. So this other side is going to be the square root of 1 minus x squared. All right, let's put now we're going to use that to put everything in. So what this statement is saying is find the cosine of that triangle. So what's the cosine of the arctangent triangle?
1 over √2.
Good job. All right, this is saying find the cosine of what? The arc cosine triangle. All right, so what is the cosine of this triangle here? X over 1. Technically, couldn't I have done this? Because don't this cosine and the arc cosine cancel each other out? But it's okay to read it out of the triangle too, okay? All right, this one is saying find the sine of the arctangent triangle. So what's the sine of the arctangent triangle? 1 over square root of 2. Square root of 2 over 2 would work too. Okay, if you're going to rationalize in your head, I'm going to wait and do that at the end. All right, this one says find the sine of the arc cosine triangle. So in this second triangle, what's the sine of it? Over what? So the square root mess over 1. All right, what's the common denominator going to end up being? Square root of 2. Yay, right? All right, this numerator is going to be x. We're going to subtract, and this numerator is going to be the square root of 1 minus x squared. It is possible that that is a valid answer. Yes, I know there's a radical in the denominator. Okay? However, that might not be the answer, and we might have to rationalize. So if you rationalize these two, you're already probably done. Okay? So I'm not going to try to distribute that. I'm just going to leave it out front. I don't remember or know what your book is going to do. I would say this is an acceptable answer. Okay? Because distributing that in is going to make it look super ugly. Okay? It's already ugly enough. All right. I'm going to skip 13. 13 is almost identical to this. So I've done one of that type. Okay? And let's go to 14. 14 is going to do the same idea, but we're going to use our unit circle. So we've done one with right triangles. We've done one with that has the arcs in it, right, with right triangles. And now we're going to do one that is based off the unit circle. Okay, so if you don't have your unit circle, at least the quadrant angles of your unit circle, we need that. Okay. All right, so what's the cosine pattern? See, isn't it nice to just know that and not have to look it up every time? Okay. You'll have to look up all the ones for the section 5, so you might as well know some of them. All right, what operational symbol are we going to put in first? Negative, because for cosine we do opposite. And then I'm going to write in sine inverse of 0. And then oh, sorry, not of 0. What am I doing? -1. Don't let me do it wrong. Okay? Make sure you catch my typos. All right, cosine inverse of 0. And then I'm going to write in sine inverse of -1. And cosine inverse of 0. All right. Let's talk about sine inverse. Okay. So, let me write this. So this is 1, 0. This is 0, 1, -1, 0, and 0, -1. Okay, so we're looking for where the y value is equal to -1. So what radian measure does that happen at? At which one? What? This one down here. What's this radian measure down here? 3 pi over 2. I like it. And it's not going to make a difference in this particular problem. But remember when we learned inverses, we renamed that to -pi over 2? Okay. Technically, that's the correct answer. Okay. But you get the same thing even if you use the 3 pi over 2. Okay. I'm going to write the correct answer. And then, yeah, I still need cosine. All right, cosine. What's the cosine inverse of 0? So where is my x value a 0? Is at pi over 2. That's right. Okay. Sorry, I was looking at the wrong line. Okay, so at pi over 2. And remember, cosine's only valid in these 2 quadrants, so we're not worried about this one down here. Okay, what happened? Oh yeah, because that was sine. Okay, minus sine. Okay, where is the y value equal to -1 again? 3 pi over 2, or in this case, we really should write -pi over 2. And then it's the same thing here with this one, right? It's the same as this measurement here, pi over 2. So we don't have to really think about the second part again. All right, now we're going to think unit circle again. I would need to find the cosine of -pi over 2. So what's the x value down here? 0. Awesome. All right, what's the cosine of pi over 2? 0 again. What's the sine of -pi over 2 or 3 pi over 2? -1. And then what's the sine of pi over 2? 1. So the zeros are going to go away. Negative times a negative is going to be what? Positive. So what's my final answer? 1. That's a lot of work to get a 1. I guess it's better than getting 0. At least you feel like you got something instead of nothing, right? And you've done the problem. Alright. We're going to go one more problem. So we're going to do 15 and then we're going to call it good, I think. Okay. Alright, so we're supposed to find the value of the expression without using the calculator. This time they want us to do tangent. It's kind of similar to the last time. Let's try something a little bit different with it. Okay, I want to see if this works. Alright, I don't usually do it this way, but let me try it. So let's see if we can find the angle measures first and then do our pattern. Okay, so I think that'll work on this one. The cosine inverse of -square root of 2 over 2. So I need you all looking at your unit circles. Okay. Cosine is only valid in quadrant 1 and quadrant 2. So which y value, or which radian measure for that x value in those 2 quadrants? 3 pi over 4. So we're going to do 3 pi over 4. All right, what about where in these two sine is valid in these two quadrants, right? Where is the sine equal to 0? What radian measure? 0, good. All right, that looks a lot better than trying to write this out a bunch of times, right? Okay, so what's our tangent pattern? What sign do I start with in the top? Negative, and then it goes 1, what? Positive, and then we're adding or subtracting in the top, and what are we doing in the bottom? Multiplying, and then we're going to plop in the 3 pi over 4 twice, right? And the 0 twice. And you can't just discount the 0 because in trig world, we need the 0, right? It actually be as a number sometimes. All right, help me out with the work. I'm going to set that little skeleton up there. What's the tangent of 3 pi over 4? It's over here. Let's see, wait, 3 pi over 4 is here, isn't it? Should be -1. Looks like I have the wrong answer last year. So it'd be -1 and -1 there. All right, what's the tangent of 0?
0.
It's 0, right? Because it would be 0 over 1. All right, so this wipes out. So what is it looking like my answer's going to be?
1.
-1. All right. I said that's where I was going to stop it, right?
Yeah.
16, the only big difference is we've actually kind of done this before. It's just writing your triangles out again. It's just a 5, 12, 13, and 8, 15, 17. Okay? So I'm not going to do that again. All right? All right, give me a minute here. I will get a homework assignment posted. Let's see. I don't want to do, let me write down what I want here. 31 to 57. We're not going to do that first. We can do 35. A big eraser? If you look in the boxes, sometimes there's a big eraser in those. They can do those. They can do these. 57. This should be, okay, so 57. Okay. All right. Okay. All right, I think I've got it. Let me get it up there for you. Number 68, right?
The poster.
All right, if you refresh, it should be there now. Okay? I skipped all the verifying because we didn't do it, right?